but it actually reduces NOx without the use of diesel exhaust fluid. But the majority, 99% of all manufacturers are going to use SCR in conjunction with DEF fluid to reduce NOx. So this was really pretty much integrated into 2010 plus emissions in on highway. Now, if you're here with off highway, that's great too. The tier levels are a little bit different, but the concept's the same. SCR is the same. So 2010 plus emissions is when the SCR catalyst, really started to become integrated into the systems. 07 to 09 after treatment was added, but that was just a DOC and a DPF. Again, we got a whole other webinar for that. But in 2010, the addition of SCR was added to most vehicles. Now, does the engine influence SCR conversion efficiency? A lot of you are here probably, I'm going to guess, that you've had some SCR conversion efficiency codes, and sometimes that's hard to navigate. So I'm going to help you with a flow chart to kind of help you get through that regardless of what manufacturer you're working on. There's some basic principles we can use to make sure that we get this sorted out. But one thing that I always talk about, especially with regeneration temperatures and SCR issues, what does the engine have to do with it? Does the engine influence SCR conversion efficiency? And absolutely it does. Remember, one thing that I saw in the field very common was technicians would have regeneration issues or SCR conversion efficiency issues, and you automatically start to focus on the after-treatment system. And I understand that, right? But the after-treatment system is there to clean up a dirty engine. So if the engine is running excessively dirty for whatever reason, then the after-treatment system is going to have a really hard time keeping up with that, and SCR especially. So what does the engine have to do with it? Everything, right? If you have SCR conversion efficiency issues, if you have regeneration temp issues, if you have DPFs that are sitting up too quickly, anything that's affecting the after treatment, my number one rule is to go to the engine and find out what's wrong. Now, is it always the engine? No, it's not. But the engine is something that's forgotten about. The engine is something that people look at last, and it really needs to be something you look at first. Are there any associated fault codes, right? In other words, when you have an SCR conversion efficiency fault, is there any other fault codes on that engine ECM or on that ACM that are referencing anything that has anything to do with engine performance, reliability, efficiency? If there is, you need to address that first, right? So if we have a intake manifold pressure sensor fault and we have a conversion efficiency fault or a regeneration issue fault, we need to start with that intake manifold pressure sensor and find out why it is not working correctly, because that has a trickle effect downstream. And one of the terminologies you've heard me say if you've been to any of my other trainings is upstream issues, upstream being the engine, upstream issues turn into downstream catastrophes, downstream being the after treatment. So one small issue on the engine multiplies itself. By the time it gets to the emissions package, that issue is really starting to wreak havoc. Okay, so keep that in mind. So before checking the SCR system, it's important to verify there are no upstream engine issues. Always make sure your engine is working properly, efficiently. Okay. Now, my next question is, talking about upstream issues, does EGR play a role in SCR efficiency? Okay, so when we talk about EGR, when we're talking about exhaust gas circulation and on-highway heavy duty has been basically around since the early 2000s, 2000, 2001, 2002. Detroit started implementing it around 2002. It became mainstream in 2004. 2004 is when most manufacturers implemented EGR into their diesel engines. Now, the whole reason I'm bringing up EGR, and you're probably wondering, Scott, what are you talking about EGR for? EGR was put on the engine first as a way to reduce NOx in cylinder. So in 2004, they started monitoring NOx, and they wanted to start reducing NOx, and they did that or tried to combat that starting with EGR. Now with EGR, what's happening is we are essentially taking recirculated gas from your combustion chamber, previously combusted gases that enter your your exhaust manifold. We take them through a cooler to lower those temperatures, and then we introduce it back into the intake air path. So that exhaust gas or that previously combusted gas that is very, very low in oxygen content is going back into the intake assembly to go back into the cylinder. Now, why are we putting EGR back into the cylinder? Well, in a very short way to put it, it's to reduce cylinder temperatures. Okay, when you reintroduce very diluted oxygen gas, previously combusted gas, into your intake and into your cylinders, what you're doing is you're keeping the nitrogen and the oxygen molecules from binding inside the combustion chamber. So when that happens, there is a heat reduction. There's also an efficiency reduction. Okay, there's some things that are byproducts of that. But by keeping the oxygen and the nitrogen from binding, you're lowering cylinder temps, which lower cylinder temps equal lower NOx output. NOx is created when we combust a fossil fuel with a high oxygen concentration and we create a lot of heat. So if we can reduce that heat, if we can keep the nitrogen and the oxygen from binding, we'll lower the cylinder temperatures, we'll lower the NOx that comes out of the cylinder. Now this is really important. Even though we're talking about SCR, it's really important to know that, because if you have an EGR issue upstream, then you're going to have excessively high NOx coming out of the engine. And if you have excessively high NOx coming out of the engine, which would be monitored with your NOx inlet sensor, NOx inlet sensor is generally mounted very close to the turbocharger. It could be before the DOC or right after, depending on manufacturer. But it's essentially what's coming out of the engine, how much NOx is coming out of the engine itself. So if our EGR is not working properly, or if we have poor air-fuel ratios, or if we have poor EGR flow, or if we have restricted EGR coolers, or very low efficiency EGR coolers, we're creating too much NOx in cylinder, which is going to trickle downstream. And then it's essentially too much NOx for the SCR catalyst to be able to deal with. So an upstream issue such as an EGR issue or an air-fuel ratio issue can lead to SCR conversion problems only because it's too much NOx for the SCR catalyst to be able to do anything with. All right? And that'll make a little more sense as we get a little further. But my main goal here is, remember, if you have after-treatment issues, regardless of whether it's regeneration or SCR, make sure you're checking that engine. Okay. Now, selective catalyst reduction. That's what we're going to be going over. All right. Here's kind of a very generic picture, I guess. But what I want you to see here is when we're dealing with selective catalyst reduction, we're essentially dealing with a new system. So if I were to draw a line here, if I were to cut this system right here, from here back would be your SCR system. Now, remember, this system here is responsible for reducing NOx. And we do have a NOx outlet sensor, but we also have a NOx inlet sensor. So even though this is upstream, this sensor is still responsible for this section of the exhaust, essentially, right? So in 07 to 09, we had a DOC and a DPF for particulate matter and oxidizing that soot. But we still have this system. In 2010 and newer with SCR, we still have the DOC and the DPF. They've just added a secondary system here, okay? It's just a piggyback system that is now added. So we're going to go through these components. We're going to talk about the things they've added, and hopefully you'll have a little better understanding here. So before we get started, let's talk about DEF fluid real quick. I don't want to go into a huge drawn-out thing with DEF fluid, but it's really important to understand a few things about DEF. DEF has a lot of different names. Okay, we got blue DEF, we've got urea, we've got AdBlue, a lot of different terminology. It's all the same thing, okay? It's made up of 67.5% deionized water, and it's 32.5% urea. Now, this is really important because the first step you should be making when you get into an SCR issue, the first physical measurement you're going to take should be checking your DEF fluid concentration. It's a real simple thing to do. Okay, you need a DEF refractometer. We sell digital, we sell manual. You can buy them off tool trucks, you can buy them off Amazon. You can buy these things anywhere, but if you're going to be a technician working on SCR related issues, you need to have a DEF refractometer. And what that's going to do is that's going to tell you what concentration of water to urea you have. And the number you're looking for when you're using that DEF refractometer is 32.5%. You're checking the urea concentration. Now, a general rule of thumb is the spec is 32.5% plus or minus 1%. Now, if you go get some brand new DEF fluid out of a jug that's fairly fresh, within 8 months to a year old and has been sealed, and you were to check that DEF fluid with a refractometer, it's going to be 32.5 plus or minus a quarter of a percent, right? You're going to see 32.3, 32.2 and a half, something like that. I mean, very, 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 very close to 32.5. But in the field, as long as you're roughly within 1% of 32.5, you're going to generally be okay. Okay, so my standard, my gold standard is 32.5 plus or minus 1%. So essentially 31.5 to 33.5. Now, that's a very easy step to make, and why is it so important? I was a tech at a dealership for my 15 years in the field, and I saw all kinds of things in DEF tanks. I've seen coolant, I've seen diesel fuel, I've seen gasoline. How they got gasoline? Who thought that was a good idea? I can't answer that, right? I've seen straight water. I've seen just about everything in a DEF tank you can imagine, and that's sometimes, not the fault of the driver. Sometimes it's, sabotage, and sometimes it's just the driver doesn't know. Nobody told him what to put in there, right? So it's a real simple step to make, and without urea, your conversion's not going to take place. Okay, we have to have urea, and we have to be roughly that 32.5%. Now, what is urea? Urea is a compound of nitrogen that turns to ammonia when heated. It's also used in a variety of industries, including as a fertilizer in agriculture, okay? Now, it's a very basic substance. It's used, believe it or not, when you purchase food that's been through a processing plant, a lot of manufacturers actually have urea refractometers to measure how much urea, how much traces of urea is in the food that you're eating because it's used in agriculture, okay? So when it first came out, a lot of people said it was like jet fuel, it'll burn your skin off. You don't want to drink this stuff, okay? You don't want to get it in your eyes, but it's fairly safe to handle. It's nothing like they made it out to be in the beginning, okay? Do not put additives in DEF. It will degrade the quality and cause performance issues. DEF fluid does not need anything other than DEF fluid. You don't need de-icers. You don't need any kind of DEF boosters. It's not like fuel. You pour the DEF fluid out of the jug straight into the tank. That's what needs to happen, okay? If you have DEF fluid that's not 31.5 to 33.5% urea, you need to drain it and fill it out and refill it, okay? So nothing's needed to be added to DEF. Now, one of the nice byproducts of DEF fluid is DEF fluid freezes um, at 12 degrees, but it also evaporates, right? So when we get hot, when we exceed, roughly boiling temperature, I guess, and it doesn't even have to be boiling temperature. It can just be hot over a long amount of time. Just depends how fast this water will evaporate. But just like water would do if you left it in a cup in a hot environment, water is going to evaporate. Well, when the water evaporates from DEF fluid, that leaves you with urea. And urea, when the water is evaporated from it, will naturally turn into a solid substance. It won't stay liquid by itself. It needs that water to be liquefied. So if the water evaporates, what you're left with are crystals. You're left with a solid substance of crystals. Okay, so if you're looking at an emission system and you see white crystals all over a component, you have a leak there, right? So super easy to find leaks with DEF fluid. Just look for crystals. Like I said, it freezes at 12 degrees. So obviously there are places in the U.S. and across the world that it gets much colder than 12 degrees Fahrenheit. So there has to be some way to make sure that DEF fluid can unthaw. So DEF fluid tanks have some form of heat source. They either use an electric heater or they use coolant wrapped lines. So they actually move coolant through the DEF tank, through the sending unit. So there's a couple different ways that they can actually unthaw this DEF fluid. But it's important that you make that happen. Otherwise, in very cold climates, you can't inject a frozen block of DEF. So you've got to get that thawed out. Now, usage rates. Why are usage rates important? Well, I mean, in the field, I had a lot of guys ask me, a lot of drivers ask me, hey, I'm not using that much DEF fluid, and I think something's wrong. Or they might say, hey, I'm using a lot of DEF fluid, and I think something's wrong. So the average DEF usage rates are from 2 to 7%. Some can go as low as 1%. Okay, so like your little Ford 6.7 and an F350, or a little 6.6 Duramax and a 2500 or 3500. In a very light duty cycle, you might only use 1% of DEF fluid. Now, when I'm saying 2 to 7%, that's the average. Okay, that's a good range that you can determine if something's excessively being used or not at all. So the quickest way to quantify that usage rate is 2 to 7%. If it's using a 2% usage rate, then that means it's going to use 2 gallons of DEF for every 100 gallons of diesel. If you have a very high duty cycle with a lot of load on the engine and you're using that higher percentage of DEF to try to lower that NOx, if we were up to that higher percentage rate of 7%, then you'd be using 7 gallons of DEF fluid for every 100 gallons of diesel fuel. So there's a ratio there you can kind of use to pinpoint, just how much it's actually using. So anything between 2 to 7% is pretty normal. Now again, talking about that DEF refractometer, here's a picture of a digital DEF refractometer, very easy to use. The DEF refractometer is used to precisely measure the amount of urea concentration in the DEF. Again, we're looking for 31.5 to 33.5, optimum being 32.5%. Again, that's a super quick, super easy test you can do right up front before you get started. Okay. Now remember, with your DEF refractometers, you're going to have to calibrate these when you use them. So you're going to want to calibrate that to 0 using distilled water. Okay, so every time you calibrate your DEF refractometer, get you some distilled water, 0 it out to 0%, dry off the lens, and then actually take some DEF fluid out of your tank, put it on the lens, and then you should be seeing that 32.5%. So let's talk about some typical SCR components, right? What are some of the things that we see on these systems? What are some things that it has to have? Well, first of all, we have to have a DEF tank, right? And that DEF tank is going to house our DEF tank sensors, right? So depending on year model, it could be what they call a QLS sensor or a quality level sensor, which is a smart device, or it could be a very basic analog sending unit that just measures level and temperature. So depending on year model, depending on make, you could just be monitoring level and temperature, or you could have a QLS or a quality level sensor, which is a smart device, which will actually measure the quality, the actual percentage of DEF, and it'll use a sight sensor or an ultrasonic sensor to do that. And it would also measure level and temperature all in one sending unit. Of course, we have to have DEF lines. We have to have some way to get the fluid out of the tank and get it to the doser, right? DEF lines are going to be heated because, again, DEF fluid freezes at 12 degrees. So we need to have some lines to de-thaw that and get that fluid moving. We got to have some sort of DEF pump. Okay, we got to have, again, we've got the lines that connect the DEF tank to the doser, but we got to have some way to actually pull a suction on the fluid in the tank, build that pressure, and send it to the doser. We have to have adequate injection pressure to our DEF doser in order to get adequate DEF into our decomp tube so the reaction can take place. So we'll have a DEF pump of some sort. Then, of course, like anything else, if we're injecting a fluid, we're going to have a doser. Now, these DEF dosers come in a couple different styles, and I'll show you those as we get a little bit further. The DEF doser is going to be used to inject diesel exhaust fluid into the decomposition tube. The DEF doser will be mounted directly to the decomposition tube. So when you can find your DEF doser, you found the inlet to your SCR catalyst. So it's kind of a roadmap to figure out, where does my DPF and DOC end? Where does my SCR catalyst begin? And of course, the decomposition tube, we'll talk about that as we get a little further. And then we have an SCR catalyst, the actual catalyst that the chemical reaction will actually take place in order to reduce those NOx, nitrogen oxides. Of course, like anything else on a vehicle, we don't want to have a conversion happen. We don't want to have components just doing whatever they want, right? We have to have some way that monitors what's actually taking place inside those components. So with this system, we'll have inlet NOx sensors, outlet NOx sensors. We'll generally have temperature sensors in the SCR catalyst. Not all manufacturers use them. And then some manufacturers will have what they call an NH3 sensor. So here would be an outlet NOx sensor. This would be your SCR outlet temp. This would be your SCR inlet temp. And then this right here would be your NH3 sensor if it had one. So If this is the inlet of your SCR catalyst, this is the outlet of your SCR catalyst. If you look in the very center of that catalyst and you see a sensor with about 8 wires coming off of it, that's going to be your NH3. Again, not all manufacturers use them. Some manufacturers built trucks with NH3 sensors and then later actually made them where if you replace the catalyst, there was no place to put the old sensor because they wanted you to get rid of it. NH3 stands for ammonia. Okay, so it was monitoring how much ammonia slip was taking place. Again, let me get a little further and that'll make a little bit more sense for you. All right, so the DEF tank. The DEF tank will be heated by an electric heater or by engine coolant. Okay, so depending on manufacturer, they could have an electric heater mounted to the bottom of this tank, maybe along the walls here, which is just resistive heat strips, or the majority are going to use engine coolant, which the sending unit would have coolant that actually flows through the large stainless steel tubing in it, and as that coolant from the engine flows through this tubing, it will thaw out the DEF fluid inside of this tank. Again, the DEF tank is going to house the level sensor. Again, that could either be a quality level sensor, which is going to measure quality of DEF fluid. So your ECM, if you were to connect your service tool, you would actually be able to see what percentage of DEF is in the tank without the refractometer. You still need the refractometer in case that DEF sending unit is reading biased. You need something to compare to, right? So that's why we need that refractometer. Or again, you could just have an analog level and temp. It could just only measure analog level and temp, and it'll do that through resistance, right? So resistance will go up or down depending on temperature or level of fluid. Now, you'll notice these DEF tanks are always black plastic. They're plastic because DEF fluid does freeze, so it needs to be able to expand when the DEF fluid does freeze so the tank won't bust. And it's also black, not see-through plastic, because sunlight can harm DEF fluid. DEF fluid that is exposed to sunlight for too long, it can actually begin to slowly degrade the DEF fluid inside of that tank. Now, if the DEF tank is heated with engine coolant, the system will use a coolant control valve to supply and shut off heated coolant to the tank. So again, like I was talking about here, if coolant is what's flowing through these lines or through this sending unit itself to thaw out this tank, you don't want coolant flowing through these tubes all the time because you don't need the DEF tank getting abnormally hot. If DEF fluid gets abnormally hot, then it'll begin to degrade. So you don't want DEF fluid at engine operating temp all the time, right? That's not something you want. So if it's frozen, the coolant control valve is going to open. It's going to allow coolant to flow through the sending unit until the tank begins to thaw, and then the coolant control valve will then close and stop the flow of coolant through the sending unit. That's going to basically give longevity to the sending unit and the DEF fluid. Okay, both of those are going to do better when they're not in extreme temperatures. Okay, now the reason I'm telling you about this is if the valve was to stick closed, if this coolant control valve was to mechanically freeze shut, or if it were to mechanically fail shut, then your tank will never unthaw. And if you can't get your tank unthawed, then you can't get DEF fluid into your decomp tube, which means no conversion is going to take place. Now, this coolant control valve could be mounted on a frame rail. It could be mounted to the sending unit itself. Like for an example, Freightliner, their sending unit, the coolant control valve is part of the sending unit on certain years. And then, like International, some other manufacturers, they actually mount them to the frame rail. So they could be in different places. So just be aware of that. And the last reason why I'm talking about this is because if the valve were to stick open, let's say this valve is to mechanically fail in the open position, that means the coolant is going to flow through that sending unit all the time. And if coolant's constantly flowing through the sending unit, then over time, that temperature of DEF fluid inside of that tank will eventually get up to engine operating temp. And it can do that multiple times. The problem with that is these site sensors and these ultrasonic sensors, if it has a QLF that monitors your actual DEF ratio, they do not like to be in hot environments for a long time. So if they are, what will happen is that sending unit ultrasonic site sensor, or excuse me, ultrasonic or site sensor, the sensor that's monitoring the DEF fluid ratio, it can fail due to extreme temperatures. So one of the things I saw in the field was we had a couple trucks that were coming in pretty regular, about once a month, and they had the same fault code, DEF tank sending unit, Quality level sensor, open. So we'd check it, and it was open, and we kept going through it, and we'd put a sending unit in it, come back in a month, put another sending unit in it. Come to find out, the coolant control valve was stuck open, allowing coolant to flow all the time, which was allowing that sending unit to get too hot, which in turn was causing these sensors to fail. So if you have a vehicle that's having QLS problems, over and over and over, you need to definitely investigate this coolant control valve because it will cause issues for you. Um, just see if it's stuck open, stuck in the open position. These valves are normally closed, which means without power or ground supplied at our electrical connection here, no coolant should flow through that valve. Now, when we're talking about DEF lines will be heated as well, either with electric heaters or again by coolant wrap lines. So we see here, this top picture here is of a electric heated line. The lower picture here is of a coolant wrap line. Now, the most common version you'll see will be these electric lines here. That's the most common version. But these coolant wrap lines do exist. They are out there. And then, DEF lines will supply DEF fluid from the tank to the pump. And then you're going to have a return from the pump back to the tank. Okay, so whatever's not being used will basically just come from the tank and back to the tank. And then generally you're going to have a line that comes from the pump and goes to the doser. Now there are different manufacturers that do it differently, right? So some manufacturers only have two lines now, one from the tank to the pump and from the pump back to the tank, but the pump is incorporated in the doser. So there's just different types of scenarios out there. At the end of the day, what you need to be aware of is how are they getting fluid out of the tank to the doser, and how are they getting fluid back from the pump to the tank, right? We just got to get fluid out of the tank to the doser. That's the main thing you want to focus on, right? Now, I put two really common pumps up here. I can't go over every pump that was built, but the Bosch Diagnostics, this has a huge part of the market share for SCR related issues. They put these on on off-highway machines. They use this on highway machines. This is a heavy duty pump, so there will be a lot of flow coming through this pump. This is produced by Bosch again. Probably the most common pump in the field, to be honest with you. Huge market share. But when this pump is energized, when I turn the key switch to the on position in a vehicle, one thing you're going to hear immediately happen if there's SCR on the vehicle and there is a pump, especially with this one because it's really loud. When I turn the key switch to the on position, you're going to hear that pump kick on and start priming. Okay, so that's one of the ways you can kind of tell if the pump's even coming on. You should hear it, Now, when this pump is running, if you're testing the pump, you're doing a system leak test where you're using your service tool. You can go in and run a test on the pump, which overrides it. This pump has an internal regulator. So anytime this pump is turned on and pumping, it's going to produce 130 psi plus or minus 5 psi. So it's going to produce between 125 and 135 psi. Okay, again, very common pump. But if it's running, it's internally regulated, so you should see that 130 psi. Some models will have multiple nozzles for suction and return to the DEF tank, and will also have suction return from the dosing injector. Others will only have two ports, like I talked about earlier, one from the tank to the doser and one from the doser back to the tank, because the doser is integrated with the pump. So we see here we got three lines, right? So we have one line coming from the pump, or from the tank to the pump, one line coming from the pump to the tank, and then one line going out to the doser. Okay, so this one just has three lines. This does have an integrated filter located here. Okay, so if you're not getting that adequate pressure like you think you should have, or that 130 psi we're looking for, make sure that you know there is a filter inside of this assembly right here. And then also, one of the failure modes that was really common with this, we saw it a lot, it would give you electrical faults. DEF pump pressure, signal out of range, maybe short at the ground. It depends on the different faults, but this is where your electrical connector plugs in. So this is a white plastic cover. There's a seal behind this plastic cover right here that's inside of this pump, and that seal keeps the DEF fluid in the pump from getting out to the electrical connector. Well, that seal would go bad. So it wasn't uncommon to disconnect your electrical connector here and find all these pins just super corroded because DEF fluid will highly corrode pin terminals. So if you have a bunch of electrical issues that are related to DEF tank or DEF pump pressure, and you do have a Denoxtronic, make sure you unplug that connector and check for corrosion because we saw that quite a bit. Now the next one I'm going to show you here, this is a very common Bosch pump as well. This is more for light and medium duty. But if this pump is running and this pump is on, you're going to see between 75 and 77 psi. So that's during a system leak test. If you want to run that with your PC, or if it's just running and you're dosing DEF fluid because you're just driving down the interstate or whatever you're doing, you're going to see between 75 and 77 psi. Again, this is internally regulated. Now at this pump, you're only going to see one external line because this pump mounts directly to a tank and the suction and return is built into the tank. So on this particular pump, there will only be one external line and it will be located from here to your DEF doser. Okay. Some models, again, will have multiple nozzles. This is the same statement that I just made. It's redundant, but just some information there for you in case you run across those. Those are the two most common light duty and heavy duty pumps that we have seen in the market share. All right, so the DEF dosing nozzle. This is going to be mounted onto the decomp tube. Okay, so the decomp tube is essentially where your DEF fluid is injected into the assembly. Okay. So basically your exhaust fluid passes through the emissions package, and once it passes through the DOC and the DPF, depending on manufacturer, that orientation may change slightly. But as it passes out of the DPF assembly, the decomp tube is going to be mounted in between the outlet of the DPF and the inlet of the SCR catalyst. Now again, there are a couple configurations where that changes in light duty vehicles, but this guy here is going to be dosing DEF fluid into the SCR catalyst. There's two different types here, as you see on the screen, that are super common. Now don't get this confused with a after-treatment fuel injector. Okay, after-treatment fuel injectors or hydrocarbon dosers are upstream and they spray diesel fuel. The DEF doser is located further downstream and sprays DEF fluid. So this DEF doser right here, it's got three little connections here. This is the coolant controlled. Okay, so we have the DEF fluid will enter here. This is your DEF fluid entrance port. And then these two ports here will be your coolant ports. Okay, and this is a 2-wire connector, electrical connector. Here we have an air-cooled diesel exhaust fluid doser. And notice that there are no cooling ports. It is just fins. It is ribs. And air will pass across this to actually cool the nozzle. This also has a 2-wire electrical connector. DEF fluid will enter here. Now, when you're checking these electrical connectors, one thing that's kind of weird is when it's not dosing. What I've seen most common is if I check pin A to ground or pin B to ground, I see 3 volts on both pins when it's sitting still. So when we are not dosing, it's very common to see 3 volts on each pin. But once dosing starts to occur, once the after treatment control module or the engine control module energizes this valve, I noticed that it switches the power and the ground. So it pulse width modulates the ground and the power side. So both sides are switched. It's kind of a weird thing. If you got an oscilloscope, you can hook up and see that. But basically, when it's dosing, you should have 12 volts across the two. But it's going to happen so rapidly that a scope's going to be the best way to see that. But if it's clicking, if you remove it and you energize the doser, run a DEF doser override test, and it's clicking, then it's getting its voltage and ground. Okay. So what you're about to see here is a dosing nozzle spray pattern test. Now, there's 2 ways to do this, or 2 things to monitor while doing this. This is an air-cooled doser here. And one of the biggest steps that you should really take in your SCR troubleshooting, obviously after you've verified upstream, and we're going to talk deeper about these steps. You're going to want to remove that doser. You're going to want to leave the electrical connector connected. You're going to leave the DEF doser connection, the DEF fluid connector connected. And you want to just unhook it from the decomp tube, and you want to put this in a graduated cylinder and a beaker. and you're going to run a def doser override test. All right, and what that's going to do is that's going to power on the pump, and the module is going to start actuating this doser. And what's going to happen is the manufacturer is going to give you a spec. They're going to say, you know, and we're going to just use a random example because there's so many different scenarios, but in 2 minutes during this test will last 2 minutes, okay, for the specific manufacturer. Within this 2 minutes, you should receive 100 or more milliliters of DEF fluid. So we're going to need to take that doser and put it into a graduated cylinder, start that DEF doser override test, and make sure that we collect the amount of fluid that we were expecting, because if we don't, that's an indication that we have an injection system problem. So what we would do next is we would clean this doser and run it again and see if it changed. Now, I say you run the test and then clean it and then run the test again. What I saw technicians get in the habit of doing in the field is they would remove this doser, and before they would put it into a graduated cylinder and run the DEF doser override test, what they do is they just clean it. Because when you pull these dosers out, you're going to see a thick buildup of urea here, of dried urea. It's going to be so thick that you won't even be able to see the injector tip. That's super common. But it'll surprise you how well it will still flow with that much dried up urea on the face. So if you clean it and then flow test it, how do you know if that was the problem? You don't. So remove it, run the override test into a beaker, compare your measurement with the manual. If it's low, then clean it. Test it again, see if that fixed it, okay? Even if it didn't flow low, go ahead and clean it anyway. But don't clean it before you flow test it, because you need to know if that was your problem, okay? And I don't know of a manufacturer that doesn't have a DEF doser override test of some sort, because it's just a very simple way to validate how much DEF fluid is actually being injected, okay? This is what it should look like, right? We should see those nice, beautiful 3-pattern spray there. So what we're looking for is, are we getting the 3 individual spray patterns like we expect? And is it the correct amount in the time frame of the test? And again, that test, I've seen the test last as little as 27 seconds on Mitsubishi's. I've seen it last as long as 6 minutes on Cummins. So this test varies in time base. That's why you need to compare OEM, you know, measurements. You need to say this particular OEM is 4 minutes and it expects this much fluid. Never use the same basic amount, because it varies from manufacturer to manufacturer. Now what we see here is we see a picture of the decomposition tube, right? Now again, the decomposition tube is located after the DPF and before the SCR on the majority of vehicles. Again, every once in a while that configuration could change slightly. But a quick way to kind of figure out where your system is, what all your system has, and where you are in the system. DPFs and DOC assemblies are generally, as a rule, serviceable. Okay, so they'll have band clamps that you can unhook them from each other, or they'll have flanges with bolts that you can unbolt them from each other, so you can have them serviced, you can have them cleaned. SCR catalysts generally are not serviceable. By nature, they are a sealed housing. So if we were looking at this picture here, I see a V-band clamp here, okay? I see a doser here with these blue lines, and those blue and black lines always indicate your DEF fluid. I've got a doser going this direction, and then here, I don't see any V-band clamps, right? So that tells me right now, this is the outlet of my DPF. This is the inlet of my SCR catalyst. The decomposition tube is used to allow the atomization and evaporation of water and DEF fluid before entering into the SCR canister. So the decomp tube is where the DEF fluid is injected. If you find your DEF doser, you found your decomp tube, and if you found your decomp tube, you found the entrance to your SCR catalyst.